Welcome to all in online lecture series that course Advanced Manufacturing Process at chapter number 3. It is gear manufacturing. So under this lecture number 2, gear cutting on milling machine. So gear cutting, how to manufacture the gears, already learned in the chapter number 2, that is the milling machine and processes. So similarly, gear is manufactured on milling machine. On milling machine means multi-point cutter is used to manufacture the gears. So that gear cutting operation is performed by using form milling cutters. So form milling cutter means what exact shape what we want on the workpiece, that shape or that cavity is produced on the gear blank, that is the form cutter. Now gear form milling cutter may be used for this purpose. The cutter profile correspond exactly with the tooth space of the gears, and that whatever cavity is produced, okay, is always enlarged on that tooth space. The cutter is mounted on arbor of the milling machine. Already said that arbor, it is the device, it is mounted on the cutters. And how to remember that? So simply AC, A stands for arbor and mounted on that cutter C, and then mandrel, it is one of the device. On that device n number of blanks or workpiece are mounted. So simple mandrel M, reverse that word W. So remember this trick, and mandrel always mounted in number of workpieces. The gear blanks is mounted dividing head spindle. So feed mechanism is then engaged to make the blank to traverse fast to the cutter. A similar process like milling machine indexing mechanism to manufacture the gears. Simple. The n number of form cutters are there. It may be concave, convex or form, like exact desired shape. So here gear tooth profile is there. So same type of gear be manufactured on that blank. So here T slot, so T slot type. Here concave, convex types, different shapes of cutters are there. Here countersink profile. So that type of gears are manufactured. So this is the manual method of milling machine to manufacture the gears. Now we are going to see second method, that is gear hobbing. So gear hobbing, it is very simple process. It is a method to manufacture the gear, but hob is the one of the tool like screw, and that screw whatever helical teeth, so cut that slots, and that cutting edges are used to cut the material from the blank in continuous way. So that is the hob. So that's why it's a process of generating gear tooth by means of rotating cutter known as hub. So that revolves cut like milling cutters. So hub is similar to worm, equip or screw. Proper clearance of cutting action. Fluids are provided to remove the cutting material. So threads may be left or right side. So hob may have one, two or more threads. It depends. The number of teeth depends on the ratio of revolution of hob and revolution of gear blank. So three motions are remembered: motion of hob, motion of gear blank and motion of feed. So any number of teeth can be cut on the gear blank. That's why it is the continuous process. That is the basic introduction of gear hobbing. Now basic principle. It's a continuous process. This is a negative type of manufacturing process in which gear teeth are progressively generated by a series of cut with helical cutting tool. Now here observe that figure. It is a 2D figure. This is a gear blank, circular blank, also rotary motion, and this is the one of the hob having a like worm a screw. Helical teeth are there, and that teeth have a number of slots like this. So that figure is nothing but this. So here number of helical teeth and these slots are there. So that's why these unidirectional cutting edges are provided, so that continuously rotating with the gear blank, and their gear blanks forms as these slots as the teethed on the periphery. So that is the gear manufacturing method. So observe here to review that at exam point of view that diagram is very important. Now we are going to see how it works. So gear hobbing process, the hob and gear blanks mounted on the shaft that are right angle to each other. The hob axis may be horizontal or vertical. The machining of spur gear, the hob must be tilted through the helix angle to result in the involute profile. Means as you get involute profile, so that hob may be tilted. The hob and gear blanks are rotated about their axis with different speeds. Blank is then moved downward the hob until the proper depth is reached, because that is the feed. Now just observe, this is a hob and this is a gear blanks. So when hob is rotary motion, so gear blanks is also rotary, but that speed gets different. So now every teeth of the hob to cut the material from the workpiece, and then that workpiece is continuously moves in downward direction, that is a feed, and thus to form the remove the material from the gear blank and to manufacture the exact gears. So as soon as the proper depth is achieved, the hob is fed in direction parallel to the axis of rotation of gear blank. This enabled the teeth to be gradually cut over the full face of gear blanks, and both gear blanks and hob also rotary motion. Now feed is in upward direction. So as a result, generation of teeth on the blank periphery, because that operation is continuous. So thus gear cutting with the hob involves three basic motions, that is rotation of hob, rotation of blank, and axial advancement in downward direction, that is the hob of feed. Now advantages of gear hobbing, because this is the integral method of gear manufacturing. So it is a faster and continuous process, because in each revolution have to cut two or more teeth from the material of gear blank. So rate of production is high, because that cuts several teeth simultaneously. High accuracy can be machined. So many gears of the same size can be cut simultaneously, because number of gears mounted on that mandrel. So it can cut spur gear, helical, worm and sprocket or spline. So gap type herringbone gears can be generated only through this process. It is a major advantage of this process to manufacture these herringbone gear also. Then long shaft and spline can be easily accommodated on this process. So irrespective number of teeth, same hob can be used for the same module of gear. So module means diameter of that blank upon number of teeth, that is T. So limitation of gear hobbing. Every process certain limitation, but that process cannot manufacture internal gears, or it can this continuous process, that's why cannot cut the gears which having shoulder or flanges or extended portion. So simply says that it cannot produce a symmetrical shape, only produce the symmetrical shape. Application. It is used to produce spur gear, helical gear and worm and wormwheel types of gears. Now second one method is gear shaping. So whatever desired shape to the gear blank as to manufacture gear, that shaping process of gear manufacturing. So gear shaping is a gear generating process. It is adopted by two methods, that pinion cutter generating process and rack cutter generating process. So students, you have to assume simple rack and pinion. Rack and pinion. So here rack have a linear teeth, pinion has a circular teeth and small gear. So as said, pinion cutter generating process. So pinion cutter generating process, pinion as a cutter, standard cutter, and rack means as a linear strip as like a billet to form the gear tooth on that rack. So this is the pinion cutter generating process. And rack cutter generating process, rack as a standard teeth and used as a cutter and to form the profile on the pinion blank. So pinion having a blank, so that form the gear cutting. So now it is a basic principle of that shaping machine. Cutter is mounted with its vertical axis and reciprocated up and down sliding motion with vertical way of machine. So that reciprocating motion of cutter and blank also, and rotated slowly about their own axis. So relative speed of rotation of two is the same as the gear to be cut. So that is very important. Both motions having the same. So it depends. Cutting stroke, that is downward to linear motion, then return stroke upward direction, then indexing motion. Against each rotation, cutter the gear blank revolves through the revolution, where n number of teeth on cutter and number of teeth on gear blank. Now pinion cutter gear shaping process. So already said that, just remember rack and pinion cutter. So pinion cutter gear shaping process. So now just observe this figure. Here one of the gear blank is there, and then this is the standard pinion. That pinion having a cutting edges. When that pinion rotation and this rotation comes under this gap to cut the material of that pinion with this downward direction feed and to generate the teeth on that gear blanks. So that's why pinion as a cutter in this process. So pinion cutter reciprocate along the vertical plane, and gear blank is also mounted on vertical shaft and rotate very slowly against the feed in downward direction. So depth of cut giving the during the cutting stroke in downward as similar. During this process, cutter is fed radially to the gear blank to obtain required depth. That is also very important. Not only downward but radially also to get the required depth. The use of pinion makes the process continuous and rate of production is more as compared to rack cutter, so that pinion cutter is mostly used. Now pinion cutter gear shaping, this method. Then next one is rack cutter gear shaping process. So in this method, the cutter has a rack from the gear to generate it. So rack is used to cutting edges. Now for this process, that is a pinion has circular teeth. Only change the diagram so that instead of rack there is a pinion, and other than this similar process is followed to generate the gear. So gear blank is rotated slowly and uniformly about the vertical axis. So rack cutter reciprocate with the required cutting speed to remove the material from the gear blanks. As you observe these gear blanks, and when this continuously feeding and reciprocating motion, thus to remove the material from these gear blanks like this to form the teeth on the pinion. So that is rack cutter gear shaping process. So rack as a cutter, so that's why rack cutter gear shaping process. Now the cutter is radially fed to obtain the correct depth. The cutter remove the material only during the cutting stroke, relieve during the return stroke. Because cutting action in only cutting stroke or forward stroke. The reciprocating motion of cutter and angular relative motion of gear blank and gear teeth is generated on the gear blank. So the main limitation of this method is to that once full length of rack is utilized, the operation is required to be stopped. In such case, blank is indexed next and cut started as usual. This is the process of rack cutter gear shaping. So advantage of this gear shaping, it is the fast process suitable for medium and large size batch production as compared to hobbing. So most of gears like spur gear, rack, double helical means herringbone also sprocket can be generated by this process. So very close to shoulder can also be cut. So hobbing it is not used for that extended portion, but here can manufacture the gear cut have good profile. For same pitch, same cutter can be used because that is a form cutter. Both external as well as internal gears can be cut from pinion cutter process only. So that is a basic difference. In pinion cutter can cut the external also internal, but there is a limitation of rack cutter only manufacture the external thread. So you have to remember that point. So limitation of gear shaping. For cutting helical gears, special guide called as helical guide is required. When our need is that for helical teeth, so helical guide is required. Worm and worm wheels cannot be produced by these mate. So cutting takes place only in forward stroke, that is a rack planning, and return stroke ideal, so that is time is wastage. Now we are going to see that is distinguish between hobbing and shaping process. So what exactly difference of hobbing and shaping as considered to the features points? Accuracy better with respect to tooth spacing and run out equal, so far lead accuracy is required. Better with respect to tooth form depends on the tooth form, here tooth spacing and run out, so that accuracy is more. Now surface finish. Hobbing produces series of radial heads based on feed rate. You hop across the work. But here shaping produces series of straight line parallel to the axis. The surface finish may be better. It depends. Versatility cannot be used for internal gears hobbing, but in pinion method can manufacture the internal gears. So faster and gears with a larger face width, but here time cycle will be 2-3 times of hobbing for wider gears. So that is the difference of hobbing and shaping process, that points have include in your working also. Now next I would like to share that this is the last topic for the gear finishing. Before this we have learned how to manufacture that gears, and after manufacturing of gears there is a need to finishing. So why that need to finishing? Because that gears are meshing to each other, so to avoid the noise or in quiet operation, so wear and tear rate, that purpose finishing is required. So for finishing, smoother running good performance and long service life of the gears needed. So that finishing is required. To achieve the accurate in dimension and forms, get exact dimension, or to achieve high surface finish, to be hard wear resistive, means to minimize wear and tear rate, to remove inaccuracy produced through the gear generating process. Gear teeth finishing work after near accurate performing and machining can be achieved by finishing process because it remove the irregularities from the gear blanks or teeth come in contact with each other during machining. Now, what are the gear finishing processes? So, let me explain one by one. But before this, what is the gear finishing processes? The surface of gear tube produced through the gear generating process is not very accurate and properly finished as application point of view. Such a surface result lot of noise, excessive wear, play or backlash while meshing tooth or sometimes may cause ultimate failure also. So that's why finishing is required. So as finishing that methods are follows: gear shaving, gear grinding, gear burnishing, gear lapping, gear honing, roll finishing. So let's see one by one. So these are the gear finishing processes. We start from the gear shaving. So gear shaving, it is the gear finishing process and it is a negative type of manufacturing process. It removes also material in form of microns. So similar as human being shaving to remove the hairs from your face. So similar here. So that razor is required. So here also razor type gears are required to remove the material from the another gear. So here observe that this is the gears shape. Now this is the standard gear or sharp edge cutting edge provided gear. When that gear mesh on the another gear blanks, so that remove the eddies, burrs or whatever extended portion on that teeth. So that is the finishing. So cast iron cutter, enlarge view of the tooth showing serration, gear shaving, exact process. So in this process, very thin chips are removed from the gear tooth surface by the cutting edge of gear shaving cutters. So that type of gear shaving cutter that may also use as like this cutter, no problem. So gear shaving is employed to remove the material on the teeth in the form of very fine chips that size is 0.005 mm to 0.1 mm from the gear tooth. So that material removal rate is in form of microns. So that is the finishing process. So same gears as used as a sharp edge of the tool, that is a gear shaving tool. Now this cutter has a narrow groove serration on the tooth flank. This tooth more the cut edges of the shaving cutter. So this process of finishing gear tooth by running the gear at high speed in mesh with the shaving tool, which is in form of rack or pinion. So that speed should be high. The teeth of shaving tool are hardened, accurately ground and their faces are provide serration. This serration form cutting edges which actually provide a scraping operation of mating faces of gear tooth to be finished. Now gear is pressed in contact with the rotating shaving tool. That pressure also required because shaving tool is also reciprocate simultaneously. This prevent to jamming of two and relative motion between shaving tool and gear result in high surface finish on gears. Now, second one method is gear grinding. This is also gear manufacturing of finishing process. Now, same diagram as like two tools are in gear shaving. So similarly here, gear grinding. So gear as a input blank, and there is a one of the involute shape of gear tooth cutter. So that is gear grinding. Sorry. So gear grinding. So gear grinding, that gear shape and that type of form cutter as a grinding tool is used. So now another figure, that two cutters are provided for grinding. So gear operating high speed, high load are very always hardened. There is a distortion of gear blank. In order to remove this distortion, to have accurate profile on gear tooth for smooth running of gears and grinding is done. So every time you have to repeat same sentences, what is the exact need of gear finishing processes, and then at the first sentence you have to write first technical point, what is the exact gear grinding and what is the exact gear shaving or any respective process. Grinding is very accurate method, though relatively expensive, more widely used for finishing teeth, different types of sizes of gears, hard material or hardened surface. So that type of form wheel is used as a grinding. So grinding material is almost aluminum oxide or silicate carbide. So that materials are used for the grinding purpose. The properly form of the dress wheel finishes the gear tooth flanks by fine machining or abrading action of the fine abrasive. Sometimes that wheel gets dressed to remove the that raw material in form of micron. The grinding tooth is formed by truing the grinding wheel to the shape and size of the gear tooth to be finished. As you wear out the sharp cutting edge, so resharpening of that tool, similar that grinding wheel, that truing is the process. So gear is the mounted on index head and grinding wheel is fed to required depth. The gear is then withdrawn and indexed to the next tooth. Now you are going to see that is the third process, gear burnishing. So this is the cold machining methods. So here same type of gears are rotating to each other. So it forms as a cold working process to get the exact surface finish or somewhat remove the micron of materials. So that is a gear burnishing. So these three gears are used. So only rotate in each other under the pressure. So this is the cold working process to improve the surface finish and uniformity. Vertical reciprocating motions of that burnishing gears. The gears are power driven and fed to the cut gear and rotated through few turns in both directions, in clockwise also anti-clockwise, to get the exact smoothness to the involute shape of that gears, and little hardness also develop on that. The load is provided by means of pneumatic, hydraulic or electric. Pneumatic means air pressure is required, hydraulic as oil pressure, then electric, that is a motor pressure is required. So now gear lapping process. Now this is also simple figure. You have to draw again two plates like this is also what, but here gear lapping is gear respective point of view, that lapping is different. So that is a finish machine or shave, then the heat treated and finally lap to remove scale, improve surface finish on teeth and rectify small error due to distortion during the hardening process. So in this process, gear to be lapped or run under the load in mesh with one or more cast iron toothed laps so that teeth gets material should be added or removed. So that is type of cutters are used. Either abrasive paste is introduced between the teeth or fine abrasive powder mixed in oil and is made to flow through the teeth during the running. When these gears are running, so in between that powder or paste is merged and that gets is finishing purpose, that is a lapping like plastering process. A negligible amount of material is removed during this process and to improve the surface finish. That is a simple method, that is a gear lapping. Then gear honing. It is the gear finishing process of hardened gear. So honing is also one of the tool like hobbing. So honing is also one of the tools that vertical stitch have provide the abrasive materials to remove the material in form of microns. So it improves the surface finish of the tooth profile. It also reduces the noise of spur and helical gear after heat treatment and correct heat treatment errors. So that is honing. Horn is the one of the tool that provide on the periphery, that is the abrasive material. So gear tooth honing is generally carried out constant pressure between the teeth on the gear and honing tool, thus to remove the material in form of microns. On a machine tool resembling the gear shaving machine, gear honing is performed. The gear tooth horn is an abrasive embedded plastic helical gears shaped tool. So there is a honing tool. So now here just block diagram is given. So as process point of view, that is the gear and this is also gear, but that gear's teeth have provided that honing tool, means abrasive materials of that gear tooth, and that material get meshes or running on that another gear of the workpiece to remove the material in form of micron. So that range is 0.025 mm to 0.05 mm, which is suitable for honing allowances as well as required of surface finish. Thus get the surface finish exact of the gear honing process. So that honing tool is now like similar to gear shaving tool, that sharp edge is provided, but here not sharp edge, that abrasive tools are there, tips are there, that is a honing tool. So that is the gear honing process, and that processes are used for to gear finishing purpose as like to improve the surface finish, to reduce the noise quite in operation, also increase the service life of that gears. So that purpose gear finishing methods are used. Also rolling is also method, so similar type of rolling is also method. Same type of gears can roll in for more rotation in clockwise and anti-clockwise like burning action. So that is also rolling process. So I hope you have understand these gear finishing processes. So we have covered here in the third chapter, that is gear manufacturing and finishing processes. So under this finishing, shaving process, gear grinding process, lapping process, honing process and rolling process. Thank you.